All right, in this section, we're going to be talking about the chi-square test for a single variance. So when would I use this? You would use if you were testing a single sample and looking for a possible change in the variance of the sample to the population variance, and also standard deviation, because remember, variance squared is equal to standard deviation. And I don't have it in parentheses here. So what are our assumptions that we need? Well, if you're testing for a single variance, we're going to assume that the underlying distribution is normal. The test statistic that you're going to compute is chi-squared equals n minus 1 s squared over sigma squared, where n is the sample size, s squared is the sample variance, and sigma squared is the population variance. We think of s as the random variable in the test, and the degrees of freedom are going to be n minus 1. Let's do an example. The average waiting time in a doctor's office varies. The standard deviation of waiting times in a doctor's office is 3.4 minutes. A random sample of 30 patients in the doctor's office has a standard deviation waiting time of 4.1 minutes. One doctor believes the variance of waiting times is greater than originally thought. So, as always with our hypothesis test, the first step is to state the null and alternative hypothesis. One doctor believed the variance is greater than originally thought. So, that's our alternative hypothesis, that sigma squared is greater than 3.4. The variance, remember the variance is just sigma, and we're given the standard deviation, which is sigma squared, but if sigma is bigger, so is sigma squared. So we're going to assume that sigma squared is greater than 3.4. Well, actually, for numbers bigger than 1, if you square, you're going to get a bigger number. And these guys are both bigger than 1. And our null hypothesis will be that the waiting time is equal to the population standard deviation of 3.4. So which distribution will we use? Well, we're going to use the chi-square distribution because this is a test of a single variance. Our n is 30. That means our degrees of freedom is 29. And our test statistic is n minus 1 s squared over sigma squared. N minus 1 is 29. The sample standard deviation is 4.1. The population standard deviation is 3.4. Compute that all up and you get chi-squared equals 42.17. So we're going to go to our handy dandy chi-squared calculator on Desmos. We enter 29 for our degrees of freedom. We enter our 42.17 as our chi-square statistic that we just calculated, and it tells us our p-value is 0.054213. And so that's that purple area right here has an area of 0.054213. So now we need to make a decision and write a conclusion. Well, our p-value is 0.05 something, 0.054213. That is bigger than 0.05, so we do not reject the null hypothesis at a 5% significance level. Our conclusion is there is not sufficient evidence to conclude that the standard deviation of wait times is greater than 3.4 to 5% significance level. Wait, there isn't an Arcibeti calculator for this one? I can't seem to find it if there is one. If you guys have one, you guys find something out there, let me know. But no, I don't have one. However, there are many online calculators to calculate your p-value for a given chi-square degrees of freedom and statistic value. You can use Desmos like I'm using. I encourage you to do that because Desmos is available in your tests. And I like the graphs that Desmos gives. So there is a simple test of a single variance.